This is lesson 1.4, using the definitions of the trigonometric functions in trigonometry. There will probably be several videos here, so I suppose we should call this 1.4a. So we're going to talk first of all about reciprocal identities. We've already said that sine of theta is opposite over hypotenuse, or y over r. And then we said that cosecant is its reciprocal, and it is r over y. So, sine of theta, and let's say that we're looking at the reciprocal, and we're going to leave it in sine form. So we're going to put a -1 up here, showing that we're talking about the reciprocal, -1, and that's going to be r over y, which is the cosecant, right? We took this, flipped it upside down, and lo and behold, it's that there. So the inverse of sine is cosecant. The inverse of cosine is secant. The inverse of tangent is cotangent. Okay? So therefore, the sine of theta equals 1 over the cosecant of theta. That's an identity. If you look on the bottom of page 27 in blue, it gives you all the reciprocal identities. So the sine of theta equals 1 over the cosecant of theta. And the way they got that is the sine of theta equals 1 over, well, the cosecant of theta is r over y. So I just replace cosecant of theta with r over y. Alright, now if we take this as a fraction, 1 over 1 over r over y, and we invert multiply, we get y over r. Y over r. Is y over r the sine? Yes, it is. So the sine of theta is y over r, but it's also equal to 1 over the cosecant of theta. Now, you don't have to learn how to do all of that, or remember how to do all of that. All you need to know is the identity on page 27, the reciprocal identities, because you will use those later on. So, we can write sine of theta equals 1 over the cosecant of theta. And we will be using these identities later. Just write them down for right now. We can also write the cosecant of theta as 1 over the sine of theta. We can also say that the sine of theta times the cosecant of theta equals 1. So we can put that one identity into 3 different ways. So obviously, in order to get this step right here, we took this times this. So this was just like over 1. We cross multiplied. And that gave us this one right here. And if we keep going, we divide both sides by sine. And that cancels, and we get cosecant of theta equals 1 over sine of theta. So that's how we get the second one. So we just manipulated this one here in order to get the next 2, is all we did. So let's look at example 1a, and a lot of this doesn't make sense until you actually end up doing examples, and then it kind of clicks together. So let's do letter A. It says, what is the cosine of theta if the secant of theta is 5/3? Well, I'm going to look back at my reciprocal identities, and I know that the cosine of theta equals 1 over the secant of theta. Well, if the secant of theta equals 5/3, then all I have to do is put in, instead of secant of theta, I just put in 5/3. Then I invert and multiply. So I'm going to multiply by 3/5. When I divide fractions, you invert and multiply, and that gives me 3/5. So the cosine of theta, if the secant of theta is 5/3, is 3/5. Let's look at letter B here. And we have, we're looking for the sine of theta if the cosecant of theta equals negative square root of 12 over 2. So again, we look back at our little chart, and the sine of theta equals 1 over the cosecant of theta. So we're going to take this and plug it in for that bottom there. Flip it upside down and multiply it. That gets rid of that. So we get 1 times 2 is 2 over negative square root of 12. So the sine of theta is 2 over negative square root of 12. So we have to simplify this. So let's keep going. Let's kind of move this up here a little bit so I have some room. So 2 over negative square root of 12 can reduce to 2 over negative 2 square root of 3. Okay, square root of 12 reduces to 4 times 3. Take the square root of that and bring that out there, and we've got 2 square root of 3, and that's where that came from. Alright, so we've got that, and we're looking pretty good. The only thing is you cannot have a radical in the denominator, so we multiply the top and bottom by that radical. We don't have to worry about this 2 right here because it's not in a radical sign. And that gives me 2 square root of 3 over 2 square root of 9. Square root of 9 is 3. So 2 square root of 3 over negative 6, because I take this 2 times square root of 9, which is 3, and I get a 6. This part here reduces to 1/3. We can take that out. So actually then our answer is negative square root of 3 over 3. So that's example B.